You're listening to the Not Just Numbers podcast, a conversation with mathematicians on their work and their lives to get to know them and discuss common biases and misconceptions. Hi everybody, welcome to Not Just Number. With me today there is Marit van Straaten, I'm Marcello Seri, and two special guests for the day.
Hello, we're joined today by Henk and Alef, who are professors here at the university. And today we will talk with them about what it's like to study mathematics. But first off, let's introduce our guests a little bit. Maybe they want to do that themselves. Alef, let's start with you.
Yeah, so my name is Alef Sterk. I'm an assistant professor at the Bernoulli Institute. I teach courses. In addition, I also do research. And as a program director for the bachelor programs, I'm also responsible for the curriculum.
So that's a lot that you do.
Absolutely.
What kind of research do you do? How would you explain it to people who are not familiar with mathematics at all?
So my research is about systems that evolve over time, and they do so in a deterministic manner. That means that probability and chance does not play a role. And even though you have a deterministic system, it can still behave in a very unpredictable way. And that's the kind of systems that I try to study, and we use different tools for that. Sometimes I use analytical tools, so I do pen and paper work, but sometimes I also use numerical work, so I use my computer. So that's in a nutshell the kind of research that I'm doing.
Okay, right. Is there like a very trivial example that people might recognize from their day-to-day life that is such a system?
Well, maybe it's not a trivial example, but I think the weather is an excellent example of a dynamical system. So that's a system that evolves over time, and there's a good reason why we cannot predict the weather for more than 2 weeks ahead. It's an intrinsic property of the system that even if you know what is happening today, the system is so sensitive to changes in the initial state that it is impossible to predict what will happen in 2 weeks' time.
Oh, okay. So if I want better forecasts for the weather, then your research will hopefully help to manage that.
That's one of the aims to say a little bit more about predictability of such systems and what are the limits of predictability. You can, of course, think about weather in general, but you can also maybe think about specific things like extreme weather events. Are they necessarily less predictable or even better predictable? That's the kind of questions that bother me.
Yeah. Oh, that's very interesting.
That's fascinating. Now, Henk, I'm curious to know how your research is, if it's close or far away from what Alef is doing. But first, please introduce yourself.
Yeah, thank you for having us. My name is Henk van Waarde. I'm also an assistant professor in applied mathematics. So part-time I teach, and the rest of the time I work on research. My research is in the area of systems and control theory. So nice overlap with Alef's work is that we also study dynamical systems, so systems that evolve over time. But in our research, the goal is also to shape the behavior of dynamical systems. So we want to come up with controllers such that the behavior of this system is desirable in some way. For instance, stable or have very good performance. So you can think of examples in industrial systems, engineering systems, like robotic systems, where you'd like to change the position of a robotic manipulator in some way.
Yeah. Also sounds super interesting.
Yeah.
Like, it's a great pleasure to have you guys here. So why do you guys do what you do? So basically, how did you get into this type of research, into this type of field? What are your drives and motivations? Maybe Alef can start.
Yeah, so I basically got into this field when I did my PhD studies. So I did my master's degree in a very pure topic, pure analysis. But it was very hard to find a PhD position in that field. So then I decided to make a switch to dynamical systems. And my promoter at the time, my PhD advisor, Professor Henk had a project that was tied to, well, a mathematical analysis of climate models, where you have a model for the atmosphere and you have a model for the ocean. And basically the question was, is it possible that the atmosphere induces certain temperature oscillations in the ocean? So that was quite a switch, because I grew up with doing very pure mathematics, and now I basically made a switch to much more applied mathematics, but I liked it. I do like that interaction that on the one hand you have applications, and on the other hand you have tools, mathematical tools to analyze those applications, and that's a very, very nice experience.
Right. So very useful research also.
Yeah.
Yeah. And then after your PhD, did you immediately think, okay, I want to pursue a career in academia?
Yeah, actually, I already knew that before I did my PhD. Since I was a student, I already knew, well, I like research. I like, figuring things out. So a scientific career for me was the most natural path. And after my PhD, I continued into a postdoc position at the University of Exeter in the United Kingdom. I basically expanded my horizon. So there I started to study extreme events. And then once the ball is rolling, you keep continue what you're doing. Yeah, that's how it works.
Is it just the ball rolling, or you have some deep motivator inside you? Is it this pleasure of discovering and figuring things out? Is something else? What drives you?
I think it's a very basic drive that almost every scientist has. It's to understand things, to get your fingers behind something, to get a grip on something. It's very, how can I put it? It's very, bothering if you don't understand something. There's a sort of feeling, I have to understand this. That's a sort of, almost like a rage, if you can put it. I mean, you have to understand it.
I can relate with that a lot, and I see also Henk is nodding, so I'm curious, what is your drive?
Yeah, so I very much like problem solving also, and then sometimes it becomes a bit addicting. So you're working in the evening, and you really have to solve this problem, and it becomes this obsession almost. I enjoy it very much.
And was your path also so linear in the sense that you already knew you wanted to do research and you just kept going and straight with that?
So I started studying general mathematics, but at a certain point I switched to systems and control because of courses taught by Harry Trantelman here at university. And I thought that systems and control theory, it's so elegant, I want to study this. Then in my master, I was offered a PhD position, and it was for me, really the natural choice to continue doing what I like. And then after my PhD, I did a postdoc first in Cambridge and also a short postdoc at ETH in Zurich. And then I came back here as an assistant professor. So things evolved, I would say, in a natural way, yes.
Actually, it's quite interesting. I didn't realize you were also a student here. So you're both alumni of our university and back to our university.
Yeah.
Very interesting. So now we have discussed what is driving you. We have discussed how you get here, but why did you start studying mathematics?
So at the end in high school, I enjoyed mathematics already. And I debated a little bit about different topics to study, so I also looked into biology. I went to one of the students for a days in mathematics, and I was very much impressed there. So I think Roel Luppers had this very nice slide, where on the one hand he had this video of like this aquarium, where water was filled in this aquarium from one side. And then on the other side of the slide he had this simulation of this aquarium, and looked almost precisely the same. So I was very much impressed that day. To be honest, also because at the end of the day there was a nice dinner and we had a lot of fun. But from that day on, I knew, I really want to pursue mathematics.
And did the study also meet your expectations?
Yes, I would say so. Although in the beginning, there was for me a bit of a switch from going from high school to university. So I think this is something that many students experience. So really the attitude needs to change a bit in university, and you feel that in high school, you can go to the lectures and everything will work out fine. But in university, you need to put in effort. And that's something that I felt as a student.
I recognize it.
Yeah.
Definitely. Yeah. What about you, Alef?
So when I was in secondary school, I got very interested in computers. So I did a lot of programming. I taught a lot of programming to myself, read books about it. So I was almost inclined to do computer science. And I do like the very fundamental aspects of computer science, like how does an operating system work? How does a computer internally work? But I also learned at that time that mathematics can be very useful. So, of course, I took mathematics in secondary school. But when I started programming, I also started learning about, okay, we have the sine function and the cosine function. And now we can actually use it to, say, rotate an object on your screen. So that was a very, very nice experience for me. I also had a very good teacher in secondary school for mathematics. And he could tell me a little bit more about the why behind certain things. So I still remember that in our textbook for mathematics that we used in secondary school, there was a little box about the Taylor series. So basically you can write the sine function and the cosine function as an infinite polynomial. And that was very magical to me, because if you look at that infinite polynomial, you would not even guess that it would be a periodic function. So then you start thinking, why is that? So what's behind all this? And yeah, during my secondary school, I started to think maybe I should do mathematics. Also with the idea that if you do mathematics, you can also go to computer science. But the other way around is much harder. So that was, for me, the ultimate decision point. Okay, I'm going for mathematics.
Are there still some computer science aspects in the work that you do now?
Yeah, I do programming, but I would not call it computer science. I do like aspects of information theory because it has connections with dynamical systems again. So there's always this tendency to, well, still look at certain subjects in computer science, although I'm not doing computer science. But I do like it. It's something that has never gone away, this kind of interest.
Ah, that's nice to hear. Do you think you would also have been doing a PhD and a postdoc, becoming a professor, if you'd studied computing science?
I think if I would have studied computer science, I might have ended up in industry.
Right. That's interesting.
I think I would not have continued the scientific career path. Also because the job opportunities are very different, I would say. So when I was a student, I started in 2001. That was basically at the pinnacle of the internet boom and the dot-com bubble. And yeah, it was a very different time back then. But I'm glad that I made the switch from computer science to mathematics, that I started with mathematics and not computer science. Even though I like it, yeah.
Yeah, that's great to hear.
Now I'm going to derail the discussion a bit, but you said if you were doing computer science, probably you would be in industry. But is it because you think that there are different jobs opportunity for mathematics or computer science, or is different nowadays? Are you saying mathematicians can only do academia? Let me be like devil's advocate here.
No. But I do feel also, if I look at computer science as a discipline now, you still see that also a lot of their research nowadays is coming from industry. They really have very strong connections with industry. I think much less in mathematics, where I think in mathematics you have more freedom to pursue certain questions that might not have any societal relevance, but a scientific relevance or just a personal interest. And I think that's different from computer science nowadays.
That's very interesting. We should think of having an episode for computer scientists to check what they think about this.
Ooh,
Thanks
maybe.
for the input. And you do system and control, which is also some kind of applied flavor. Do you actually agree with this?
Well, yeah, of course, it has an applied flavor, but I would say that we still do mathematics, and that's something very important. So we work on the mathematics behind control systems. we do have collaborations with the Engineering and Technology Institute here. But you see that the type of research is still slightly different. But it's very nice that there are these applications, and I also, I'm involved in some joint projects where we also apply certain tools that we've been developing on robotic systems, for instance. And I also enjoy that.
I'm stand with both of you on this sense. I really like mathematics, whereas abstract and just about the language and understanding itself. But I also like to know that I can connect it to reality and use that for my intuition. And also know that this is actually used in other sciences and in real life as a building block language somehow is part of the reason I like mathematics as well. Although I probably disagree on one thing, or maybe I misunderstood something, which is I see many of our students studying mathematics, but then living and actually working in industry. I think that the analytic skill that they are getting by studying mathematics and the flexibility in learning perhaps computing or mathematics applied to whatever, economic, business management, development, actually turns out to be a very valuable and looked out skill from industries.
Yeah, definitely. I agree. Yeah. So this podcast is also to show a little bit the people behind math. We've talked about mathematics now and what you kind of do. What do you do besides mathematics in your free time? Any hobbies or particular interests that you would like to share?
So I read a lot of books. In secondary school, I absolutely hated it because you have to. But I think halfway during my PhD, I rediscovered my interest in reading. So I'm always reading books, always. I think on average, I read 30 books a year. So that's roughly one book every 2 weeks. Depends a little bit on the length of the book, of course, and how easy or how difficult to read.
What kind of books do you read?
Literature. So now I'm actually reading a lot of books by Japanese author Haruki Murakami. Mm-hmm. And I never read something from him. And he has this trilogy, Q1884. It was the first book that I read, and then I was basically hooked. So now I'm basically reading everything that he has written. Yeah, that's how it works. Maybe it is also something that is related to me being a scientist. If you like something, you become obsessed with it. Yeah, that's very typical. Also, Henk mentioned the word obsession, and that also applies to me. Once you do something, you spend a lot of time on it. It's either everything or nothing. Yeah, that's how it works.
It's funny to hear because Q1884 is also on my to-be-read list at the moment. A friend of mine was really enthusiastic about it. So that's nice to hear that you're also recommending it.
Absolutely. Read it because you will love it.
Nice, yeah.
I have to put it on my list then. I knew the name of the author, but I never read anything from them.
Yeah, it kind of scared me because the book was split in 3 parts for her. And it's really, really thick.
Yeah, but the chapters are relatively short. And it's also written in a style that's very pleasant to read. It's not a chore to read it.
Right, that also helps.
Yeah.
Okay, interesting.
I'm actually worried because I can see this thing about the obsession on the topic very, very well on me. Yeah. I never thought it was like we are all like this. It's very interesting, actually. And what about you? What are your hobbies or passions outside mathematics?
Well, I would say that mathematics is also a bit about solving puzzles, and I have one hobby that connects to that. That's playing board games. It's also very nice to do with friends and family members. So I like especially strategic board games. So games like Agricola, Wingspan, also like chess. So that is one hobby. And I recently also picked up gardening because we moved out of the city center to a small town south of Groningen. It's called Annen. And now we have a nice garden, so I grow all these nice plants and vegetables. there is a slight obsession going on because I want to grow as many vegetables as possible in small space. So
Optimization and control.
exactly, yeah. So very much related, I would say.
Yeah.
So I already harvested, I think, 165 zucchinis from the garden.
Wow.
No way.
You said it's a small garden.
It's relatively small, yeah, but optimized, of course.
What do you do with so many zucchinis?
Well, many of my colleagues have zucchinis from our garden. Let's put it that way. Yeah, so these are some things I like. Yeah.
Oh, nice.
That's wonderful. So let's try to go back then to the second part of the episode. You mentioned at some point that your move from high school to secondary to university showed you that there is a big difference between the two, and that you move from some place where you are comfortable that if you just attend the lecture and study everything works fine, to a place where much more engagement is required to you.
Yeah.
Is this just engagement, or is also a different way of studying once you move from high school to university?
So, well, it's also about putting in effort, I think, and learning to become more mature. And maybe there's this misconception about mathematics that mathematics is something that you just do, right? You go to an exam and then you can either solve the problems or you cannot. But that's really a misconception, because in every field of mathematics there are certain tools that you need to learn before you can really work with this and solve problems in this area. So in that sense, studying mathematics is hard work. You need to study and find out these tools. And that is something that you experience, I think, in first year of studies already. You need to attend tutorials. You need to become familiar with the topics. So that's also something that I experienced. For me, it was also quite natural, though, because it's something that you, from high school, something that you want to really do. So you're very much interested in the topic. So you automatically put in a lot of time. I don't know if it makes sense.
Yeah,
It makes sense to me.
Sense.
Yeah, I recognize this a lot. I think I also talked about it during the last podcast. That in high school you're actually being told you have to do this exercise, that exercise. And then here, of course, there are some tutorials, but you kind of have to do everything yourself in your own time, with your own motivation and being determined to fully understand the mathematics that you're learning. And that's, for me, at least, a big difference between high school and university. What about you, Alef? Did you also find a big difference, or was it more like a smooth transition?
No, the transition was hard. Fortunately, I was a kind of student in secondary school. I had to work for my results. So I was already used to the idea I need to put in effort to get good grades. But even with that mindset, if you enter university, things go so much quicker. The amount of material that you cover in a certain period is astronomical if you see it for the first time. And I found it also very difficult to make a distinction what is important, what is not important. Because in mathematics, every little detail seems important. So, for instance, when I took my first linear algebra exam, I spent a lot of time on understanding the theorems and all the nitty-gritty details, but I did not put so much effort in, say, the calculational part. How to solve a system of linear equations. And then you get an exam with exactly that. So I didn't do so well on that exam. I believe I passed, but figuring out what is important, what is not, getting used to the amount of material, also getting used to the level of abstraction that is way more than in secondary school. It's no longer about computations. It's about understanding things and putting things in a different language. So, the transition was hard. Absolutely. But I survived.
Just as a curiosity, so you were a student here. Did you know him as a student?
Yes. Henk took my course on analysis of manifolds when I first came here in 2013.
True.
Yeah.
Oh, wow. How was he as a student?
He was a good student.
You're safe now.
Do you still remember my grade?
No, I don't remember, but I think it was a good grade.
I also don't remember, actually.
I can look it up for you if you want.
Would be nice.
So what was the big change you saw, Alef, from studying mathematics in high school to study mathematics at the university, in the actual way you were studying?
Putting in more effort, but also what is different in university, you have a lot of definitions. And definitions are really important because I always tell my students, if you don't know the definitions, you literally do not know what you're talking about. So getting acquainted with definitions, what does a certain word mean? What does a certain concept mean? That's really important. You don't have that in secondary school. Questions are always of the type, compute this, solve that. But it's very computational. There's hardly any logic involved or step-by-step thinking. It's like performing an algorithm. An algorithm that is taught to you, and you have to execute it. So that's different.
It's also a very big preconception that I come across when I tell people that I study mathematics. They just think that I compute stuff all the time. Mm-hmm. But sometimes I do, but a lot of it is also just very abstract thinking about theorems, definitions, how everything comes together. And it's funny that you indeed highlight this difference between high school, where you have to calculate radians and integrals and stuff, and then you come to university and it's more about prove this theorem, make these logical steps and conclude that this is true. So that's really interesting to hear. And I was wondering, do you guys also recognize the struggles that you had when you were a student or just starting as a student in the students that you're teaching now?
Yeah.
You're teaching a first year course?
Yeah, I teach a first year course on analysis. And yeah, the struggles that I had are also the struggles that the students now have.
How do you see that? How do you see that they're also struggling?
You see it in the way that they answer certain questions that they still have not really, not always mastered the concepts. And maybe that's just not such a bad, well, maybe I should put it differently. Mathematics is a very long learning process. It takes really a lot of time to really understand something. I think also a misconception is if you have completed a certain course, and even if you have a good grade for that course, it does not really mean that you understand it. Getting a good grade for a course is just implying at that moment in time, you were able to solve those questions. That's it. But true understanding, I think it takes years. I still learn things, even for a first year course that I teach. A new example or a new way of putting it or a new way of thinking about it. I think if you really want to understand mathematics, you need to try to explain it to someone else.
That's so true. Do you recognize also yourself and your student? You're also teaching Henk a first year course, right?
Yeah, I'm teaching linear algebra 2 together with Jaap Top. Well, I definitely recognize certain things. Also, indeed, students have to be more comfortable with more abstract notions. That is definitely true in linear algebra 2 because you make this step from linear algebra 1 where it's more like computation with matrices and vectors, and you learn how to multiply a matrix with a vector, these sort of things. Whereas in linear algebra 2, more the focus is on vector spaces and more abstract notions. And yeah, some students, I also struggled with that in the first year of mathematics.
Do you have any suggestion to get used to this level of abstraction, to learn how to deal with it, to understand it?
Well, it very much takes time and practice to get used to this. So I think the tutorials are one of the nice aspects that we have to make students familiar with the concept. But sometimes this understanding also comes after going through the entire course altogether. And in essence, the exam of a course is also just an imperfect way of assessing students, right? It's we as lecturers are also very much restricted in the sense that we have 2 hours in which we have to make this, or the students have to make this exam. And somehow every topic of the course should be represented in that exam. But it's always going to be an imperfect representation for the course, I would say.
Yeah, indeed.
If I can hop in on this question that you asked about students, how they can get more familiar with the abstractness and stuff. From my personal experience, I've been a student here. I'm a master's student now, but I've been a first-year student a couple of years ago. And I always thought, I immediately have to know how everything works. And being able to accept that that's not true. It's okay if I understand only 50% of the lecture or less. And if I work through the tutorials and then look at it again at home and look at it again before the exam and during the period, you don't have to understand everything immediately. We have multiple lectures. You have a full period in which you are allowed to get used to the abstractness of a course. And I think if you're first year, it can be very stressful having put the pressure on yourself. Oh no, I need to understand everything. I need to understand this lecture, this abstractness immediately. When I'm a teaching assistant, I always try to tell people who are a bit stressed about this, like, you have time. It's okay if you don't understand fully. Sometimes you just need to digest.
Yeah, that's so true. And sometimes it's also good that you don't do it alone, right? I remember when I was a student, very often it was super useful to just chat with my friends. I'm really not getting this. Did you go anywhere with it? And then perhaps they had an example or some other way of putting it, perhaps different from what the professor or the lecturer said. And that was just spot on for my understanding. Very often, I think, as lecturers, we don't realize that we have forgotten at least some of the things we were struggling with. And we have a misconception what might be hard and abstract and what might be easy and obvious. And it's much easier for a peer student to recognize what you're struggling with sometimes than for us. And so discussing it in a cohort of students, be it at a tutorial or being together in the library or at somebody's house or whatever, for me it was possibly the most valuable thing. And perhaps it's still what drives my work. If I think about my research, I don't like to work alone. I like to work with others, and I like to basically discuss things with them because it helps me figure out what I'm doing. It's somehow the external voice that allows me to focus my thoughts in some sense. I don't know if this resonates with any of you.
Yeah, I think discussion is a very useful tool to understand things. That's what I also notice in certain type of mathematics students, that they all want to do it by themselves. And I don't think that's such a good idea. Of course, you need to have moments on which you work on yourself, without having anyone else around you. But from time to time, you also need to talk to people, because it's way more efficient. And as you said, somebody can have an example that clarifies things, or somebody can poke a hole through your logic. That's very useful. Because it's all too easy to fool yourself that you think you have a watertight reasoning and you forgot a little detail. That's how it works.
It's very true that discussions are helping us figuring things out, but sometimes you are scared to discuss because you fear that everybody else understood, and then it's just you, and then somehow there is this social pressure that makes you want to avoid asking to your lecturer, but also asking to your peer, or even show your, if I can put it in quotations, weakness to your other peers, right? So there is this kind of, I don't know if it's true. It's my impression is that we had at my time, and still there, this fear that making mistakes is bad. Showing that you're making mistake is bad. It makes you show as a worse student or as a worse person even. When it took way too long for me to realize that making mistakes was actually the point of actually understanding something. The moment I got stuck and I figured it out, discussing, being alone, or in some other way, those are the things that I still remember.
I recognize this fear of being wrong in a kind of sense as a student, because a perfect nightmare would be that you say, oh, I don't understand how this works. And someone laughs at you and says, oh, are you stupid? It's so easy. So you really have to be vulnerable. And I think a lot of lecturers do see that if people ask a question that they're being vulnerable. But among students themselves, sometimes there is this atmosphere where people are like, oh, I know everything and I have to know everything. And I can't show other people that I'm not secure in my mathematics.
Yeah, I think some students would also be hesitant in their first year to, for instance, go to the professor, knock on their door, and that is absolutely fine, of course. But there is this maybe this tendency to try to figure out things for themselves. Maybe there's also the misconception about mathematics in general, that we have these figures like Perelman who just work by themselves on this topic for so many years, are a little bit maybe detached from reality, reject Fields medal, these sort of things. Well, personally, I very much enjoy discussing mathematics with students and colleagues. I very much enjoy on the board meetings, for example, where both of you start writing, and it's very nice. It's very enjoyable, I must say.
Yeah, even when it's not working out and you are going into rabbit hole and you find out you're wrong and it's frustrating, it still was actually a nice way to spend time together and try to figure things out. And at least to me, it happens more often than not. Like the standard is that especially if I'm doing research, when I try it the first time, the second time I go nowhere. And I keep hitting walls for a while until I find the right one with a door. I don't know if it's similar with you, and I would guess it should be similar when you're studying. What do you think?
Yeah, I think I agree with you. Discussing is very important. But I think also as a student, I hesitated a lot. It's a kind of thing that you need to get over. And what I always suggest is, well, first do it in pairs. Try to find somebody who's on a similar level. You like their style of communication. But it can be non-trivial to find a good sparring partner, so to say. It's not so easy.
Yeah, I think we are all nodding, so we can all relate with
All
that.
agree,
Yeah.
yes. Mm-hmm. Can I maybe introduce another question that I'm really interesting to hear your opinions about? Whenever I talk to people and they figure out that I study mathematics, a lot of reactions that I get is, whoa, mathematics is super difficult. It's one of the most difficult things you could study. And I was wondering what you guys' opinion is of this. It's like a very big stereotype, I feel, sometimes for mathematics.
Yeah, I mean, the kind of replies that you get, it's unbelievable. So I started studying in 2001. And when I told my classmates I'm going to study mathematics, they said like, well, why would you choose for such a difficult program? If you do a business degree, you also get a nice job. So that was one of their replies. Replies from members in my family. Oh, what are you going to do? Are you spending the rest of your life on unemployment benefits? Like as if you would not be able to find a decent job with mathematics. Or you get a reply like, oh, mathematics, I was always very bad at it. End of conversation. That's the kind of replies that you get from people.
Yeah, the last one I also get. But why do you think that people have this kind of view of studying mathematics?
I think it's because the mathematics that you get in secondary school is absolutely not a reflection of the mathematics that is being done as a research career or as something that you can do in industry. People don't realize that a lot of mathematics is hidden inside of all sort of other things. So when people say to me, yeah, is mathematics useful at all? Then I always ask them, did you ever play a CD or a DVD or Blu-ray or whatever? And they say, yes, of course. So then I ask them, okay, what if there's a little scratch on your disc? How can your DVD players still play the disc. And then I explain them, okay, that has something to do with abstract algebra, error correcting codes. So that's a very pure mathematical thing that has an application in consumer electronics. And then they start to wonder, oh, I didn't know that.
Yeah,
But that's typically not the mathematics that you do in school.
that's true.
And that's where maybe the stereotypes or the prejudice or the wrong ideas come from.
Yeah, that could be a very good explanation for this. Yeah.
I know teachers in high school are already overworked and doing a massive job right now, but do you think there is something we, or together with them, can do to actually start changing this? I hope that this podcast is a small breach into this direction, but in general, is there something we can do to engage with school, with society, and show that there is value and that there is interest in doing mathematics, also the very abstract one, what you call pure, which apparently has no application, at least no direct application, and show that actually mathematics is somehow pervasive and not just something that we do in our head when we are closed in our offices in a university.
Yeah, I think having dedicated master classes for secondary school students would be very, very good thing to do. You could easily think of introducing them to modular arithmetic. And then you can already explain the principles of security. Security using prime numbers, coding theory. You can do some small assignments that don't use a lot of software. I think you need to show them something that is not part of their day-to-day mathematics curriculum in secondary school. You need to show them something that seems very abstract and yet has all kinds of applications. I think that might spark their interest.
Do you recognize these replies that you get, like people saying that mathematics is super difficult or that you're setting yourself up for unemployment in a way, Henk?
Oh yeah, absolutely. So I once told at a party the story that I was pursuing a PhD degree in mathematics. And then the person replied, but you're not getting paid for that. So that was fun. Yeah, I have gotten all sorts of replies from people. But I agree, it is related to, what we do is very abstract for the majority of the people. Indeed, one of the ideas could be to already at secondary or high school tell more about mathematics and what we do. There is this Science Links program. So sometimes we're asked to give lectures at high schools, and that could also be a nice opportunity to tell a bit about what we do and what kind of applications our work has. But I think there is indeed this big gap between high school mathematics, which is solving quadratic equations, basically, and everything we do in university.
Do you see in the topics that you work on that your research is about some topics that can actually be suitable for a discussion with high school students that they can even work on?
Yeah, I think, maybe some of the topics that we talk about in linear algebra, like Fourier series, and applying that to analyzing sound recordings, for instance, that would be a very nice topic to discuss also at the high school level. Of course, you cannot show all the details, but they know sines and cosines, and you can explain the main ideas, I would say, behind that.
Yeah, that's very interesting. That's also what lies behind, I think, JPEG compression, at least partially, right? Mm-hmm. So that could be something very tangible to them. In linear algebra, there are also other techniques. So for instance, singular value decomposition is used. Image compression, indeed. Yeah. So there are different options, of course, one can talk about.
Last year, there was also the Imaginary exhibition here at the university. And I was one of the people to be a guide and to lead classes around this exhibition. And that was also very useful. They were classes from like first grade up until like the exam year from all different levels of high school. And it was really interesting for the students to see what kind of things we do for mathematics that are more abstract and more, fun than the stuff that you do in high school. So for instance, there was like the infinite tile problem where they could try to make a infinite tile that had no repeating patterns. And the students were actually really interested, and a lot of them actually also changed their mind a little bit about what mathematics is about. So such an exhibition or stuff like that is also, I think, very helpful to show people about more the university side of mathematics.
So I see we are heading to 50 minutes. But before closing this, I'm actually curious to know if there are other preconceptions about mathematics that you are noticing in your students and that you would like to point out and demystify now for them.
Yeah, I think it has been mentioned already a couple of times, but studying mathematics takes effort. It's not like secondary school that, well, you just read a book a couple of days in advance of the exam and then you do it. That's not how it works. It takes time, and it also takes a sort of persistence. I think if you want to be a good student, it's not about how smart you are. Of course, you need brains, you need to have a sort of feeling for mathematical thought, but it's not about how smart you are, it's how persistent you are. You really need to have a high frustration tolerance. And you also need to allow yourself to be frustrated and to get stuck. That's part of the game. And I don't think that many students realize that it's just a matter of understanding it immediately. That's not the case. It's really, well, putting your teeth into the problem and not letting go of the problem. It's really a personal attitude. It's not so much about how smart you are, it's really an attitude thing.
So the movie Good Will Hunting is not a good reflection of reality, I would say.
No, absolutely not. There you have a guy that basically solves a famous question just while he's sweeping the corridor.
Exactly, yeah. Without knowing anything in advance.
That doesn't work. And mathematics has become so specialized, you need to dive into it very deeply in order to get further.
I very much agree with this. The view that you have these mathematics prodigies, of course, that there are certain people who are extremely talented, but in the end, it's mostly about hard work. It's similar in music. So my music teacher would always say in conservatory, you have people that study 6 hours a day and you have people that study 3 hours a day. And the person that studies 6 hours a day almost always wins, regardless of talent.
Yeah, I love this. This is a beautiful final note. Like mathematics is for everybody. It's about putting in the time and the effort to do it. Thank you really, really a lot for being here. It was a pleasure.
Thank you. Thank you for having us.
And thank everybody for listening. We come back in 1 month with the next episode. This podcast is produced at the University of Groningen.